In this video, I will discuss three figures from chapter 25, which deal with the integration of glycogen synthesis and glycogen breakdown and how they are regulated. So this is figure 25.3. In this figure, what is shown is what happens under the conditions where glucagon or epinephrine will stimulate their receptor. So we've gone through the G protein signaling pathway. Basically, glucagon and epinephrine are released in times of stress or times of starvation. So the end point is going to be that phosphorylase A is going to be activated. As we learned in chapter 24, phosphorylase A is the active form and is responsible for the degradation of glycogen, so the breakdown of glycogen. So under times of stress or during starvation, we're going to start breaking down glycogen. The way that we do this is by this G protein pathway. So again, the ligand binds to the receptor, either glucagon or epinephrine. GDP is exchanged for GTP on the alpha subunit. The alpha subunit activates adenylate cyclase, which converts ATP to cyclic AMP, and then cyclic AMP activates protein kinase A. Protein kinase A phosphorylates phosphorylase kinase, and phosphorylase kinase phosphorylates phosphorylase. Okay, so basically these are all activated by phosphorylation. Okay, so the pathway that I just described will show how glycogen breakdown occurs. Since glycogen is being broken down, it's also important to note that glycogen synthesis has to be inhibited. So protein kinase A and glycogen synthase kinase, or GSK, are going to phosphorylate glycogen synthase, turning it off. Okay? So when glycogen synthase is phosphorylated, it is turned off. When phosphorylase is phosphorylated, it is turned on. So under conditions with glucagon and epinephrine, we have turned on glycogen breakdown, and we have turned off glycogen synthesis. Okay. The next figure, 25.4, talks about what happens at rest or after a meal. So at this point, we want to start the synthesis of glycogen. So to follow what I presented in the previous figure, glucagon or epinephrine will activate protein kinase A. So this is protein kinase A is going to phosphorylate phosphorylase kinase. Then the kinase is going to phosphorylate phosphorylase. Okay, so this is the same pathway that I described on the previous slide. Okay, this is activation of glycogen breakdown. But under conditions of rest, when we already have a lot of glucose in our system, we want to stimulate glycogen synthesis. So what happens here is that there's an enzyme called protein phosphatase 1, or PP1, and PP1 is going to remove phosphate groups. So it's going to remove a phosphate group from glycogen synthase. So glycogen synthase B is off, glycogen synthase A is on. A phosphate group needs to be removed here to turn this on to stimulate synthesis. In a similar way, protein phosphatase 1 is going to dephosphorylate phosphorylase. It's going to remove the phosphate group from phosphorylase. When it removes the phosphate group from phosphorylase, it will turn phosphorylase off. So that's the second way in which PP1 plays a role in um, dysregulation. The final step is that PP1 can also dephosphorylate phosphorylase kinase. So again, this enzyme is turned on when it's phosphorylated, and when we take off the phosphate group, it's going to be turned off. So in this case, we have stimulated glycogen synthase, and we have turned off phosphorylase. But both of these things were done by protein phosphatase 1. So another hormone that is regulated, that regulates, another hormone that regulates glycogen synthesis is insulin. So if you recall, insulin is going to allow the transporters to go to the membrane of the cell to let glucose in, and then when we have an abundance of glucose, it makes sense that we want to be able to store it as glycogen. So this pathway is going to explain how insulin influences the formation of glycogen. So we go through the insulin signaling pathway. You don't have to remember the details right now, but eventually a protein kinase will be activated. And when this happens, this kinase is going to phosphorylate GSK. So GSK, when it's turned on, when it has no phosphate group, when it's turned on, normally phosphorylates glycogen synthase. And when glycogen synthase is phosphorylated, it is turned off. However, now the kinase from the insulin pathway is going to phosphorylate GSK. So when GSK is phosphorylated, it's going to be turned off. Since GSK is turned off, there's nothing to phosphorylate glycogen synthase, and glycogen synthase is going to be turned on. Okay. So by inhibiting this enzyme, we're basically leaving glycogen synthase on. Another way of turning this enzyme on, which I discussed kind of in the previous slide, is the idea that PP1 can dephosphorylate glycogen synthase. So again, if it's phosphorylated, it's going to be turned off. If it's dephosphorylated, it's going to be turned on. So PP1 can take off the phosphate group, turning on glycogen synthase. And this makes sense because, again, insulin the job of insulin is to bring glucose into the cell, and then if there's an excess of glucose, it only makes sense that or lead to the synthesis of glycogen. So this kind of summarizes the key figures in chapter 25. Some information was kind of a review from chapter 24, so please go back and review that in more detail.